Hi everyone. My name is Vitaliy Simikin. I'm a tech manager at YTsaurus, and I work with CHYT. This subsystem enables deep integration of the ClickHouse query running engine into the YTsaurus ecosystem. In this webinar, we will give a detailed overview of CHYT and mention its features, components, and purposes. We will also talk about its architecture, describe how queries are run, and give some general tips regarding its performance. In conclusion, we will see how to use CHYT in action based on a hands-on example. In the YTsaurus ecosystem, CHYT refers to the data processing layer. It coexists with such systems as SPIT, Spark over IT, that enables processing data from YTsaurus using SparkSQL, and YTCL that helps process data through MapReduce operations using a proprietary SQL dialect. From the user's point of view, CHYT is a subsystem with an easy-to-use UI. Basically, a user runs a certain SQL query in the ClickHouse dialect and the system delivers the result. Unlike conventional ClickHouse, where you provide the table name, in CHYT, you specify the table path to YTsaurus. That is, to the Cypress. This allows you to run queries to tables without any need to copy them to the third-party ClickHouse instances. A major part of CHYT code is based on the ClickHouse source code and gets updated with every new else version. Because of this, all new ClickHouse features also appear in CHYT straight away. The CHYT interface uses the same ATP ClickHouse does. This is why CHYT is compatible with many analytical tools through drivers and custom libraries for ClickHouse. Now let's talk CHYT administration, which is also closely related to YTsaurus. For instance, to create a CHYT cluster, or clique, as we call it, you just need to click a button in the YTsaurus UI. The automated system will then deploy and maintain it. You can deploy multiple independent clicks on a single cluster, each with its own configuration. To provide seamless operation and deep integration into the YTsaurus ecosystem, CHYT includes various components such as clicks, controllers, proxies, and more. Each of these components has its own function to perform. This chart shows all components required for CHYT to work and how they are related to one another. For those unfamiliar with CHYT, this could seem very complex and confusing. However, as we overview each component and its relation to others in detail, this chart will become more understandable. For starters, let's talk about CHYT's persistent state. The state required for every click to work is stored on the master server in the sys folder. It is made up of three components. The first one is called speclet. A speclet is a JSON document that contains various properties and fully describes the click configuration, number of instances, and so on. When a user specifies a speclet, they, in fact, define the required click state, while the system makes sure to maintain it. The second component is the so-called strawberry state. This is a system component that is required for the strawberry controller fault tolerance. We will cover the strawberry controller a bit later. For now, it's enough to say that the users do not directly manage its state. The third component are the so-called access control objects. These nodes store access permissions to non-Cypress objects, such as clicks. Using them, one can determine who has access to a click and what type of access it is. For example, you can decide who can send queries to a specific click and who can change its configuration. Such nodes are integrated into the master server, which enables not only storing data, but also checking each user's permission to access the click through the native check permission command. Now let's move to instances. This is a core CHYT's component. Basically, it is a process that is directly in charge of data processing when running a query. Instances are run within the YTsaurus ecosystems in the same way as regular jobs for MapReduce operations are. For that, one uses so-called vanilla operations. Each cluster node can have both a CHYT instance and a job for MapReduce running at the same time. You can also have multiple CHYT instances if the node has enough resources to run them. Note that instances are not bound to specific exec nodes. If a node crashes or the scheduler decides to migrate the instance to another node for any reason, everything will be okay. Finally, it is time to talk about clicks. A clique is a cluster that consists of multiple CHYT instances that are working together on distributed query processing. All instances are peers, and, since CHYT is a computing layer fully independent of the storage one, each instance can read and write data to any cluster table. If we compare it to the ClickHouse ecosystem, a clique would be a ClickHouse cluster where all instances are replicas. Or, you can think of a scenario where all instances get data from an object storage and process it concurrently. As I previously mentioned, instances do not have permanent addresses and can be restarted on different physical nodes, since they use a dedicated discovery feature to find each other. For a clique to work, you do not need all CHYT instances started. The number of instances only affects the query run concurrency and, subsequently, the speed. This means a clique can run queries even if it has only one CHYT instance started. Moreover, if a CHYT instance goes unexpectedly down, this may cause an error when running queries on that particular instance. Overall, this won't affect the system and other nodes with other instances that are processing other queries. CHYT has proxies, which are common ATP proxies in YTsaurus. You need a proxy since a clique is run within the cluster, and you, as a user, do not have direct network access to CHYT instances. This is why all queries that come to CHYT go through a proxy. Apart from just being a proxy, it also has some additional tasks. Namely, it authenticates users through a token or a cookie and checks the permissions to run a certain type of query using the respective clique. Since proxies only work based on ATP, currently, we only support ClickHouse ATP for that purpose. Finally, the last component you need to work with CHYT is Strawberry Controller. As mentioned before, CHYT instances are run within vanilla operations. An operation, however, is a temporary entity. You cannot just run it and then forget about it. It may be interrupted for the reasons that are not directly related to it. To solve this issue, we introduced the controller. This component tracks all vanilla operations run against clicks and restarts them in case they are unexpectedly aborted. Apart from that, the controller checks whether the clique's speclet is correct, and, in case it changes, it will rerun the operation with the updated configuration. Finally, it is the controller that provides an API to work with clicks and modify speclets. Both the clique CLI and the web UI work based on this API. So let's sum it up. CHYT has instances that process queries. Instances are grouped into cliques that run those queries in the distributed mode. Strawberry Controller manages running instances through vanilla operations. The controller and clique persistent state is stored in the Cypress. To access a clique, you need to use an ATP proxy. Now let's look how a query is run step by step. First, the query comes to the proxy that authenticates the user and checks whether they have the relevant permission to perform an action within a clique. Then, the query is routed to a randomly selected clique instance. The instance that received the user's query is called Query Coordinator or just Coordinator. The coordinator sends the query to the ClickHouse execution engine, and then the preparation starts. In particular, the engine analyzes the query syntax, checks whether the expressions are correct, builds the query plan, runs optimization, and so on. Note that in CHYT, all core primitive ClickHouse functions used to get metadata are redefined. Such metadata includes the info on tables, its columns, data types within those columns, and so on. Since CHYT instances are stateless, they do not store any local state. So, each time the engine wants to get such data, it has to read it from the coordinator. Then, the master server retrieves that metadata, and it gets converted into the ClickHouse format. Once the preparation stage is complete, the coordinator splits the input query into multiple parts and distributes them across all clique instances, including itself. Each such piece of the input query is called secondary query. When processing a secondary query, each instance reads the relevant part of the table and performs the appropriate calculations. Since the instances do not store anything, the reading is performed against the YTsaurus cluster data nodes. Once the reading is complete, the data gets converted from the YTsaurus storage format into the ClickHouse format and is sent back to the engine for processing. After each instance is done processing its part of the query, the results are sent to the coordinator. The latter performs final aggregation and processes the part of the query that could not be processed in the distributed mode, in case there was such a part. Then, the final result is sent back to the user through the same ATP proxy. Now let's review our table engine in detail. CHYT only has one table engine that is called Itable. It is used to readfirm and write to any YTsaurus table. Itable is a distributed engine. This means it can accept queries to YTsaurus tables and run them in the distributed mode through multiple instances. If you want to find its closest equivalent in the ClickHouse ecosystem, that might probably be the table distributor. Unlike regular sharded ClickHouse clusters, where each cluster node stores a part of a table and can process nothing but it, in CHYT, each instance can read any part of a YTsaurus table. This adds some flexibility when it comes to distributed query execution and, sometimes, enables running queries in a more efficient way. Thus, a clique may be seen as a single shard cluster with multiple replicas. One of Itable's core features is chunk prefiltering by table sorting key and min and max statistics. A chunk is a piece of data that cannot be split. It consists of multiple YTsaurus table rows. Each chunk has certain metadata available, such as limited sorting keys, minimum and maximum value in every column, and so on. This metadata may be used to exclude certain chunks based on the relevant filtering conditions. This, in its turn, enables reducing the amount of data to read. This somewhat resembles the primary and min/max skip index in ClickHouse. Currently, you cannot get such index detailed in CHYT. They only work at the chunk level. However, we are working on introducing block indexes as well. There is also PRUHERE optimization. This means Itable may read less data if there is a strict filtering condition. We also distributed insert select, which is also implemented into Itable. This means that the insert into select queries that do not require the final aggregation or sorting step on the coordinator side can write to the table concurrently without sending all data through the coordinator. This significantly speeds up the writing process. Finally, we've got distributed sorted join. This is yet another Itable's feature that enables efficiently joining to large tables if they are both sorted. I mean, joining them by the join key. In this case, the system will run the sorted join algorithm in the distributed mode, and each instance will only get the rows with the key it got assigned. Now, a few words about best practices. YTsaurus can store tables both in the row-oriented and column-oriented format. Since ClickHouse is a column-based engine, reading column-oriented or scanned tables will be most efficient. This is the best option, both in terms of input/output and in terms of converting data into internal formats. We also have dynamic and static tables. Dynamic tables are optimized for reading by key, while static ones for reading large amounts of data. For ClickHouse, the latter option is better. Static tables will get processed much faster. Also, YTsaurus enables storing data within erasure codecs. However, this feature is more suitable for storing cold data, and we do not recommend running queries frequently against such tables. Using replicated tables will most likely be a better option. Now, let's see some hands-on examples of working with CHYT. Let's go to the YTsaurus UI. We already have a cluster named itdemo. Let's open it. We can see the Cypress navigation screen. We can view both the folder contents, dive into the multi-level directories, and the table contents. Let's go to our home/demo/CHYT directory. There's a ready-to-use UC_price_paid table. Let's open it. In the top part of the screen, we can see the table metadata, the number of rows, the number of chunks, its size, and so on. This table is optimized for scanning. This means it is in the column-oriented format. The table has those 4 compressing algorithm enabled, and its replication factor is 3. In the bottom part, we can see the table preview. In this particular case, we can view the first 100 rows of the table and their values. We can also see the columns by which the table is sorted. They are marked with this icon. Let's go to the Click interface. We can see our cluster has 2 clicks. They are called ch_public and test_click. In the right-hand part, we can see their status. They are both active. We can also see the number of cores and the amount of RAM for each. We can also view detailed info on a click. Let's take ch_public, for instance. In the top part, there's some metadata. In the bottom part, there is a speclet and a special menu item dedicated to the click's ACL. In the top right corner, there are some buttons to start, stop, delete, or edit the click. We can open the Query Tracker interface right from the click screen. This is the query execution interface. Let's run a very basic query. Here, we've got the result of the Select One query. Right from this screen, you can open the full interface by clicking this button. Let's open the section for Query History and Tutorials. Let's go to CHYT Tutorials. We've got some ready-to-use queries here, including the one that calculates average price per year, using our UC_price_paid table. Let's run it. Great, we've got the result. Let me resize the windows a bit. You can use the regular ClickHouse bar function for simple number visualization. Now let's run queries that track average prices per year in London. All queries are written using the ClickHouse dialect. So, here's the result. Now let's run another query. The most expensive districts. Again, we can see the result in Query Tracker. If we go to History, we'll be able to see the results of the queries we already ran. You can also run queries in CHYT using the code. For instance, let's run some queries through a Jupyter notebook using Python and the command line interface. Here's a regular simple query. We'll count the number of rows in the UC_price_paid table. We'll run it through the ch_public click. As we can see, the result is 99,752. The same number we could see in the U. Now let's run this query again, this time through the CLI. For that, we'll use the ClickHouse execute command. As parameters, it has the click name and the query in question. Again, we got 99,752. We can also run the queries we saw in the tutorials. The visualization is not as nice as in the UE, but still fair. Now, the query on the most expensive districts. Here we go. Also, using the CLI, you can create a table, write some data to it, and request that data through the select query. Let's do it. We wrote two strings, some string that equals 10, and other string with the value of 11. Here they are. This concludes the practice part. And that's pretty much it. If you want to try our demo, feel free to go to YTsaurus Tech. You can also download YTsaurus on GitHub and deploy it in your own Kubernetes environment. Also, we invite you to join our community on Telegram. Thank you.